Hello everyone, Gaza Mutkash, and I welcome you all to this session on data cleaning with SQL scripts. So guys, let's have a look at the agenda for this session. The agenda for this session includes handling missing values in SQL tables, then handling malformed values in the tables in SQL in both let's say MySQL and Postgre, and then we'll also be looking at handling date time based data cleaning in terms of MySQL and Postgre. So prior to this session, we have discussed how to handle let's say text based data cleaning in terms of let's say trim, replace, let's say handling left, right, mid, handling positions, let's say typecasting using the cast function, and then the coolies function for handling null values, right? So in this session, we'll be concentrating on missing values, malformed values, duplicate, and even the date time based data cleaning. So let's switch to the SQL workbench. So guys, over here we are in the SQL workbench, right? So the table that I'm using over here is the customer data. Let's have a look at the table that we have. So over here I'm having the customer data for which I'm having the customer ID. This is the table that I'm creating. Let's drop the table first. All right, so the table has been dropped. So over here I do have this data. The first column is the customer ID having integer data type. Then the next column is full name with the varchar data type. Varchar it takes up to 100. Then email is again varchar that takes up to 100 characters. Phone number is varchar 20. Then address is varchar 150. Gender is varchar 10. Then we have the birth date, which is varchar 15. Then the registration number, which is varchar 30. Then income is varchar 20. And then we have the membership, right? That is taking varchar 15 characters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns in total. Let's create this table. So guys, यहाँ पे table create हो गया है, and next I need to insert the data. So I'm inserting on purpose. I'm inserting let's say the malformed values, the missing values, the duplicates, so that we can handle them. So insert into customer data. What all the columns that I'm inserting? First of all, I'm inserting the customer ID. Then I'm inserting the full name, then the email, then phone number, address, gender, birth date. Then after birth date, I'm inserting the registration TS, the income, and the membership. All right, and what are the values that I'm inserting? The values that I'm inserting are over here. I'm passing 1, and then the data is John Doe. As you can see, because I mentioned we are passing malformed value, so John Doe, the name is perfectly fine, but we have let's say extra space on the left and then extra space on the right. Then this is the email, johndoe@gmail.com. This is the let's say mobile number. Then we have the address. All right, address again contains let's say extra space in the beginning. Then we have the gender, and after gender, then we have the birth date, right? This is the birth date. Then we have registration TS. So gender, birth date, registration TS, registration timestamp. This was the time of registration. Then we have the income, and then we have the membership. All right. So the membership is either gold, platinum, silver, of this kind. Then the second one is John Smith. This seems to be fine. The email is fine. Then mobile number, then the address, then female. So as we can see, male is in uppercase, female is in lowercase. So again, not standardized. And then the birth date, registration timestamp, the salary, and then let's say the membership. Again, as we can see in the salary, couple of values are prefixed with dollars. A couple of them are not. Next, we have this Alice Johnson. This is the email. Then it contains null values. Then we have the address, gender, and then as we can see, even the data type for the date column changes. And this is the registration timestamp. Then the over here the salary is NA, the membership is platinum, and likewise we have couple of other records, right? So maybe for some records the email is null, and let's say for at times even phone number is null. Then over here we have the null as address, null as gender, and this birth date is not known, and the registration timestamp is not known. The entire row is null. Majority of the values are null. Then we have John Doe again. So this seems to be a duplicate. All right, so we have johndoe@gmail.com, and then this is the name, the email address, then the gender, even the birth date is same. Then we have this, and then over here we have 45,000 and gold. All right, so majority of the values are same for John Doe. Just that what is the difference over here? We have not used let's say we do have extra space, we don't have extra space over here. Then this is the name contains special characters, so the details are over here. So clearly we can see that let's say even the date time contains malformed values, right? The gender contains malformed values, and even the membership contains the malformed values. So to handle the malformed values, what we can do, we can use regex. Regex stands for regular expression that we'll be using for solving questions as far as this particular data set is concerned. Then after this, see for this particular, let's say Donna Paulson, the email is blank. Then we have the phone number, then let's say the address, the gender, the birth date, registration timestamp, and then the salary is again null, and the membership is platinum. And likewise, we have so many records. And clearly we can see for all these records, couple of null value, couple of duplicates are also there. All right, and we do have the null values as well. We have duplicates even over here. All right, so names have duplicates, so means majority of data has a couple of rows as duplicates, but if we treat the columns properly, only then we can identify the duplicates, right? So this is the data. Now these two columns are entirely same. It's just that the ID varies and rest of the details are entirely same, right? So this we should be able to detect properly. So we have a total of 30 records. So we have created the table. Now see, the last row is entirely null except for the ID. So what am I going to do? I'm just going to execute this, and the same data will be using even in Postgre. So I've inserted 30 records, right? Over here I've inserted 30 records. So let me show you the data. So we have customer ID, then we have the full name, email, phone number, address, gender, birth date, registration TS, income, and the membership. So let me mention the columns that we have. We have customer ID, then we have full name, then we have email. All right, after ename we have email, we have phone number. After phone number we have address, then we have gender, then we have the birth date, then we have registration timestamp, then we have income, then we have membership, and that's it. These are the columns that we have. And as far as the malformed values are concerned, where in which columns do we have the malformed values? It's present in the birth date, it's present in the income, it's present in membership, it's present in gender. All right, and even in email, even it's present in, let's say, full name, it's present even in email. Means phone number we shall not be checking, and yes, at least these columns contain malformed values, etc. There may be more. So let's understand. So the first question that we'll be solving is show full names before and after trimming. So what can be done? So over here I'll be writing full name, and so this is the original full name. All right, and let's call it, this is before trimming, before trim, and then I'll be using the trim function on the full name column. All right, I'll be using the trim function on the full name column. Let's call this trim full name, trim f name. All right, this is the trimmed full name, and then from what is the table name? The table name is customer data. The table name that we have over here is customer data. So guys, as we can see, this is the full name before and after trimming. So clearly we can see a couple of names over here have extra space, but after trimming those issues have been resolved. Clearly we do have null values as well, but so if the null value is present in the before trimming, so it cannot be resolved after trimming, right? But for my cross, see, as you can see, the trimmed details are working properly. So next we can convert the membership to lowercase. So yes, that can be done. So over here I'm having the membership. So this is the membership. This is the original membership, and then membership in lowercase. So lower of membership. All right, and this is the lower membership. And what is the table name? The table name is from customer data. So guys, this is the data that we have. We have gold, silver, platinum, gold, and this is the data that we have, right? This is how it works. So these are the results that I'm getting, and clearly we can see that everything has been converted into lowercase. Next we have convert gender to uppercase for standardization. So again the same process. So I'll be writing gender and then uppercase of gender as upper gender from the customer data. So let's call this, I'll be calling it the gender original, and then this. So we have the gender original, and this is the, so I've converted everything to uppercase. Now clearly, let's say a couple of values are male, couple of values are M, so maybe we can apply the replace, right? So we can apply replace. So how do we apply replace? Let's understand this. So we'll be writing the case statement. So first of all, we'll check what all values do we have. All right, so over here I'll be writing gender and then case when gender. So maybe we can just display M and F, right? So when gender is let's say female, then I need to display F. All right, so this is one condition. And when the gender is male, then I need to display M. All right, likewise when the gender is F, okay, so this can be converted to uppercase, so that is sorted. And then we have X. Okay, X is maybe other. So first of all, I'm converting everything to lower, right? Okay, so if I convert it to lower, then this would be female. So this is handled, and so if this is handled, even this is handled, right? So first of all, I'm converting everything to lowercase to handle the gender column, and then male. So this would be male. So X would be represented as X, and male is handled. All right. So X would be represented as X. So male female is handled over here. What else do we have? So lowercase male and female. All right. So that would anyway be converted to lower. So this is the original column, and this is the transformed value. And then male, okay, so uppercase male, so everything would be converted to M. That's it. So let's run this from the customer data. So I need to pass else lower of gender. All right, and as so this would be gender reformed. So guys, let's run this. So this is how we can, okay, customer data customer. So as we can see now, we have all the genders in the lowercase. So this is the original column, and then this is the gender reformed. So once the gender has been reformed, so else this would be upper, because I'm converting everything to uppercase. So I want to display this data in uppercase. So guys, now we'll only be getting the values M, F, and X. All right, we are only getting M, F, and X. So this is how, let's say, we have reformed the gender column. All right. So this was for standardization. This is for reforming. So let's call it maybe 3B. This is how we have reformed the gender column. Next, let's proceed to the next question. So convert numeric looking income values to integers. So we have to ignore the dollar and the comma. So because if we just look at the income column, so select, this is where regex will come into picture, income, and then let's say income from the customer data. Let's check the output. So these are the incomes, right? These are the incomes. So how do we display them? So we have 80,000, we have incomes like this as well, we have negative values as well. So let's see how do we reform them. So not every value will be reformed, but couple of them definitely will. So this is about income reforming, right? Over here we are reforming the income column. So over here I'm selecting income. I'm using the cast function to change it to integer. So first of all, I'm replacing dollars with empty string. Next, I'm whatever is obtained, I'm replacing the comma with an empty string, right? So and then let's say the output would be a string. So I'm converting this to unsigned. Unsigned is integer. So this is the income cleaned or income reformed from the customer data, where income rejects. See, income has to be numeric, right? So anything that is not starting with dollars, and then but it should be 0 to 9 with more number of characters, and plus indicates more and more number of characters. So this is what it should not start with, and this is what it should not end with, right? So this is how we can write regex to handle this pattern, and then let's say this is done. So in total we have 30 rows, but now this will not return all 30 rows. Let's see, it is only returning 15 rows where this pattern is matching. See, so for $45,000, 45,000 we are getting 45,000. For 32,000 we are getting the exact value. Next, for 45,000 we are getting the same value. For 90 it's correct. For 75 it's correct. For 65, 90, 75, 55, 1,80,000 0. And for all the values it is correct. Means whatever we have obtained over here. Now, a couple of other values we have not reformed because they were written in strings. All right. So to handle even strings, we'll have to write very long, extremely long regex code. Next, we have parse birth dates in DDMM format. So let's say I'm parsing the birth date. So for let's say to convert birth in date into a particular format, we can use the function string to date. So over here I'm writing %y %m and then %d as the parse date and from the customer date. This is the regex expression. So year has to be 4 digits, so it is 0 to 9 with 4 characters, then again 0 to 9 with 2 characters for month, and then 0 to 9 with 2 characters for date. So hyphen is over here, hyphen is over here as well. Alright, so this 0 to 9 is the range of values, 4 is the number of characters. So starting with 0 to 9 4 digits, then hyphen 0 to 9 2 digits, hyphen 0 to 9 2 digits. So this is how we can parse the birth date as well. So guys, as you can see, this is the original birth date and this is the parsed one, but I'm only getting for 30 rows because this format is only applied for 13 rows. So can I parse it in YYYYMMDD? Yes, the same can be done by writing the same thing. So this was YYYYMMDD. Okay, this was DDMMYY, no issues. Let's, okay, this was not in DDMMYY, this was only in YYYYMMDD, right? This was YYYYMMDD. So this is done. So it's the same question. Let's get rid of this. So till 5th we have seen. Next we have the 6th question. So over here we can extract let's say domain from the email. So how do we do this? So this is subject email. I'm using the substring index. So from the email, let's say I want to find the last after split, whatever is present after @. All right, that is what I'm extracting. So -1 is from the right, +1 is from the left. So where the email is not null and the email like anything before @ and anything after @. So this is the wildcard filtering that I'm using. So this is what we have obtained, right? So these are the domain names. Next, extract the first 3 characters of the full name. So I'm using the left trim full name as the first 3 characters. So this is what we have obtained. Next, we have show all the rows with at least one null field. So over here, I'm selecting star from the customer data where each of these columns contains null. So do we have null values? Yes. See, we can clearly see all the null values, right? Now, how do we count the, let's say null value exists? So over here, I'm using select count as star as total rows, then select full name. If the full name contains null, then the null in full name, then the null in email. So if email is null, if some phone number is null, if some gender is null, if some birth date is null, if income is null from the customer data. So this is simply going to return the count of null values for each column. So for full name we have 2, for email we have 5, for phone number we have 5, for gender we have 3, for birth date we have 4, for income we have 4. This is what we have. Then delete all rows where email or customer ID is null. So this is how I can delete them. So it says 5 records affected, right? So now if we check, we only have 25 rows. Can we detect duplicate? Yes. So clearly we have seen the customer ID is all unique. So I'm checking the duplicates from the full name. So full name, email, I'm not trimming the full name. So if the email is not trimmed or maybe is reformed, not all the duplicates will be extracted over here, but couple of them would. So full name, email, phone number, address, gender, birth date, registration timestamp. And then I'm using income, membership, count star as duplicate count from the customer data. And I'm grouping by full name, email, phone number, address. Again, the same columns which are present in the select statement, right? Having count greater than 1 indicating that the number of rows are more than 1. So that indicates duplicates. So clearly we can see 3 rows have duplicates, right? So guys, this is how we can handle, let's say, missing values, reformed values, and even duplicates in MySQL. Now, we'll be utilizing the same data and we will be working on the same in Postgre as well. So let's switch to the Postgre. So guys, we are in the Postgre. So this is the same data that we have, and over here I've inserted the values, right? The values are inserted. So I'll reiterate the table structure. So we have select star from the customer data. So this is the customer data. So we have customer ID, then the full name, then email, then the phone number, the address, the gender, the birth date, the registration timestamp, income, and the membership. Now from this data, what do I need? I need to handle all the problem statements that we have handled in MySQL. So first of all, I need to show full names before and after trimming. So the function is entirely same. Select full name as the original name, then trim full name as a trimmed name from the customer data where full name is not null. So if I were to execute this, so यहाँ पे हमें क्या result मिल रहा है? See, just observe the original full name and the trimmed name, right? So we are done with, let's say, we no longer have any extra spaces in the full name after trimming. Post trimming, we don't have any null values. Yes, means there are some special characters that can be handled differently. Next, we have to normalize the membership into lowercase. So how can this be done? So over here, I'm selecting membership as the original membership, and then I'm using lower trim membership as clean membership from the customer data. So this essentially cleans the membership, right? So gold, silver, and platinum all converted to lowercase. All right, and null values still persist. So we have not handled null values as far as this column is concerned. Maybe what I can write, where membership is not null. All right, I can write it like this. So now the number of records would be limited. Now I'm getting only 26 records without any null values. So next we can normalize the gender to uppercase. So maybe where gender is not null. All right, this is what I'll be implementing. So select gender as the original gender. Then I'm using the upper trim gender as the standardized gender because I wish to convert it to uppercase from the customer data where gender is not null. So once this is done, as we can see, we have male, female, and this is how we are implementing it, right? So we have reformed it even in MySQL. So can we reform this in Postgre as well? So yes, I'll be using the same query, the case statement one. So this is what I'll be implementing. This is the gender reformation. So okay, and as gender reformed. Okay, so this is the column name. So maybe this should work. Let's see. Yes, and as we can see, the gender has been reformed, right? Except for the null values, we are not getting any issues. So maybe over here I can write where gender is not null. So now it should work. We shouldn't be getting any null values. So in the gender reform, there are no null values. We only have values M, F, and X. All right. So these are the values. So now I need to convert income. We have to remove dollar and comma from the income, and we have to convert it to numeric. So this is where cast function we can use. Over here I'm writing select income cast replace dollar. Then I'm replacing comma. Let's say as numeric as income numeric from the customer data. All right, and this is the rule for the income. So it is not starting with the dollars, and it should be 0 to 9 plus means more than one characters. So I can, if I execute this, so as we can see, we are getting the values for 15 rows. Now I need to pass the birth date into ddmmyyyy format. So let's see this. So over here I'm using the toDate function, right? In SQL we have string to date. In Postgre, in MySQL we have string to date. In Postgre we have let's say toDate function. So over here I'm using let's say the birth date and toDate. I'm using the birth date and then ddmmyyyy. This is the format which I need to parse. So date has to be 2 digits, right? So dd, so 0 to 9 means date can be any number from 0 to 9, and it has to be 2 digits. Then followed by forward slash, then 0 to 9 2 digits again, so indicating month. Then y, so 4 digits, 0 to 9 it can be any 4 digit number, and then 4 characters. Now we are not let's say currently checking if the date is between maybe 1 to 31, if the month is between 1 to 12, and if the year is maybe something greater than maybe 2000 2010 or something. That is not what we are validating over here. That could be another regex. So currently we are only getting one values because maybe there is just only one value that can be transformed it into this format. Can we parse the date into mmdd? Yes. So it's the exact same code. It just that 4 digits initially, and then in between 2 digits, and then at the end 2 digits. So let's run this. We should be getting more records now. So yes, over here we are getting clearly more records, right? So this is how it can be implemented. Then we need to handle the malformed email. So select full name email from the customer data where email is not null, and email like. So this is see, this is the regex for the email. So it has to be from capital A to Z, lowercase a to Z, and 0 to 9. So it can be more than one characters. This is what I want in the beginning, then followed by @ After @ we have something like the domain name. So domain name can be capital A to Z, lowercase a to Z, 0 to 9, and then may include dot. All right, and then again a dot. So .com or maybe .in.edu. So then capital A to Z, lowercase a to Z, maybe 2 characters or more, and then end. So this is the type of email that I want. So this is the email validation. So all the emails that are following this pattern are displayed over here. So we have only 11 emails that follow this pattern. Next, I have to fetch the first 3 characters from the full name. So how do I fetch it? So over here I'm writing, let's say select full name, left trim full name 3 as the first 3 characters from the customer data where the full name is not null. All right, so over here we don't have the null as the full name. So let's run this and see, guys, we have extracted the first 3 characters from the full name. Next, we have to extract the domain name from the email. So how can this be done? So over here I'm writing select email split part. So in the MySQL, the function used is substring index. Over here it is split part. So email, I'm splitting it with @. So whatever is mentioned after @ comes at index 2. Whatever is before @ comes at index 1. So this is the split part. This would be domain from the customer where email is not null, and position in this at the rate, the position of at the rate in the email should be greater than 0. Position over here indicates the index, right? We have discussed the position in the previous sessions. So this is what we have obtained. We are obtaining the email. All right. We have obtained the, let's say, domain name only for those domains which follows this pattern, which where this logic is followed. So next I need to count the number of null values for each column. So this can be done. Select count star as total rows, then count star filter where full name is null as null. So we have used it slightly differently over here than compared to MySQL. Count star means counting number of records where the full name is null, where email is null, where phone number is null, where gender is null, birth date is null, and income is null. Same can be applied to even membership. But let's run this and check. So total rows is 30, then null full name 2, null email 5, null phone is 5, then null gender is 3, null birth date is 4, and null income is 4. So guys, this is how we have let's say handled missing values, malformed values, and we have dealt with date time, and we have used regex for data validation as well. Let's say as far as the session is concerned. So guys, that brings us to the end of this session. Let's switch to the PPT. So guys, in this session, we have understood data cleaning in terms of handling missing values, handling duplicates, handling malformed values, and handling data validation. So in the next session, we'll be, let's say, understanding the concept of views. How do we create views? What is the purpose of views? To handle clean reporting. Thank you.